Yeah, we are finishing our discussion by looking at the row types. What do we mean by row type? Let me get my pen here. So we've been creating, or we have shown you how you can create a generic class. And we've told you that the moment you create a generic class, you must specify the type as an argument when you are creating an object using that generic class. So, but when we saw previously that when we are using, or in the previous video, when we're using a stack as a generic class or generic interface, we're specifying integer or the string, or we specified even ABC as a type argument when we're creating object of that stack. So, if you have a generic class, you can create objects by specifying the type, or you can choose to create objects without specifying the type. If you don't specify the type, that becomes a row types. A row type is the name of a generic class or interface without any type argument. So you are creating your object without specifying the type argument. So this one can also be referred to using generic type without specifying the type parameter. So that's the point. You have a generic class. What is expected of you is to create objects by specifying the type argument that should be sent to that type parameter. For example, if we look at this example, we came up with this class. And this is a generic class, my class, with the type parameter t. It means when we're creating objects, we have to specify what is t. And here we were creating the first object, object 1, and our t now is integer. We're specifying that. But what we are saying is you can create another object without specifying these things. And if you do so, that becomes generic class. That's what we are saying here. So here we are assuming we have a box somewhere as a generic class. And if you create something like this, because here it's like you are creating the object of box as if it's a normal class, non-generic. And if you do this, then this is considered to be a row type. These have been added for backward compatibility, of course, because in the past, we didn't have generics. So when generics was added, they made sure that the generic code should be able to even be compatible with the old code. So we can come up with this row type because of such a thing, which was just to support, the old versions or older code. But the implication of this is that when you do this, you do not benefit from generics, so to say, because there are some advantages, as we saw in the very first video, that generics actually helps us to safeguard our code in terms of type safety. But this is now defeating that. You lose the type safety of your code. You may still have now some problems appearing during the runtime, things which would have been caught during the compilation phase. So that's the problem of using the row types. But there'll be times when this will be necessary, so you can still create object from generic class without specifying the type parameter or the type argument. So here we have our box class, and this is a generic class. Okay, we are setting, so we have a box. We want to create a box. You can create a box, and what will be inside this box? It can be integer. Maybe this is what we are putting inside the box. It can be integer, it can be string, it can be whatsoever. So this is a generic one. It can be a box of integers, a box of ABC, a box of string, a box of persons, a box of what. That's it. So it's a generic one. it has got two methods: putting something in that box and getting that which was put in the box. Two things: you put, you get out. That's this method. So you can create objects from the box. If you want to have a box that should be used to keep integers, then you specify integers as shown here. We are creating a box, and this box object has got a type argument of integer. So we have created that. So this is a normal way. It means we are using a generic class. So we can set the value and we can display that value. But here, look at this statement now. This statement is actually creating an object of a box, but it's not specifying a box of what type, despite box class being generic. It's not specifying here. There's nothing. So this is a row type. So we have created a row box. And this has got issues that may arise later, because we need to remember to do a proper casting. Of course, there will be other castings that would be done implicitly, but if you are using generic classes and you are using row types, you need to actually remember to cast your types properly, because you may have some issues at runtime. Because the row type is I've just remembered that I'm using a wrong spelling here. It should be row type here. Sorry, row type here, row type here. Not that type of row, but this type of row. Okay, so the row type here is considered probably by when erasure is done and everything is done, it's considered to be object. So you need to convert it. So here, for example, we have the reference of the box, which is integer. That reference is assigned to the object of the row type. But because integer is lower in the hierarchy, because this row type is taken to be object in our case, then this will not bring any warning. That will be okay. But if you try to do the other way around, trying to take the row type and assigning it to integer, you may have some warnings. So here we are displaying what we have there using the row box. We get the value, and here we set the value. So we may have some warning for unchecked conversion or invocation. So we are invoking a set method here, and it's complaining to say, okay, but there'll be some warning. It will run with some warnings, because you are sending integer, but yet this which you are using is a row type. We can consider this to be object class. So it will give you some warnings. And here we are displaying the values, and now we are taking the row type reference, putting it into the box. This will give us the warning of unchecked conversion, because the box is integers. The row type here, it can be considered as object class. So you're taking object class reference, putting it into a integer reference. It will give you a warning, but they will try to do the implicit casting. But there will be some other situation where the explicit casting is necessary. Otherwise, your program, despite that it has compiled, during the runtime may give you some problems. It may not work because of the row type. So I just want you to take note of this. Okay. Ambiguity. We have ambiguity errors which may arise because you are using generic methods or generic classes. That is mostly because of the use of these generic or these type parameter names. here we have two type parameter names, T and V. To the programmer, by putting T and V, they will be thinking these are two distinct data types. We have a data type T and a data type V. So here we are declaring A to be of data type T and B of data type V. So you may think you are declaring them using two different types, but who knows? So anyway, here we are setting it. The first one is a set, but for data type T, and the second one is a set for data type V. So this probably would work because they are overloaded methods. Their data types are different. The first one data type is T, the second one data type is V. So that's okay. It's like the first one the data type is integer, and the second one the data type is string. So these are overloaded methods. They have different headers, so that would work. But these are generics. We don't know what T is, we don't know what V is. The user of this class, the user may maybe create object by sending the first parameter or the first argument as integer and the second argument as integer. Because this cannot deny that. There's no way of enforcing that. It cannot deny. So the T, first T is going to resolve to integer, and the second T is also going to resolve to integer. And with that, we have now a problem with these two classes. They will all resolve into set int O. And that brings ambiguity. But the most important one should consider that these things, they use erasures, and the process of erasures, as we saw before, it actually changes all these things into object class, which is our upper bound, unless if you had your upper bound specified as we did before. We used the comparable as upper bound, and at some point we demonstrated using numbers. But let's consider that we are not having an upper bound in between. So our class, generic class, is going to resolve, or our methods are going to resolve into upper bound. So that upper bound class will be object. So what will happen? This T, because they just needed to keep one version of each method, so this T is going to actually resolve into object. Okay, anyway, object. And this V is also going to resolve into object. Now we have two objects. So it will be like set object O, set object O. Then we have a problem. So these should be taken note of to avoid having such problems when you're coming up with your program. Some restrictions that should be followed, or that should be taken note of, as these may bring some challenges to you. The first one, we are saying it's not possible to create an instance of a type parameter. It's not. And it's not possible to have a type parameter declared by the enclosing class for static member. It's not possible. If you have a static member, or maybe you have this as a member, and this T has been defined by the class, then you cannot have this method as static. You cannot have static, then T get. No, it's not possible, because the T is defined by the class. So that has to be associated with the instance methods and not static methods. Okay, and another one, you cannot instantiate an array whose element type is a type parameter. If you saw our previous video, we are using actual object to create array for our stack instead of using the T. So we didn't have new maybe new T, then this, then this, then you specify whatever here. No, we didn't have something like that. And you cannot create an array of type specific generic references. And finally, a generic class cannot extend throwable. We cannot use a generic class to create a generic exception class. So these are some of the limitations. Thank you guys.